All right, in these next few videos, I am going to kind of give you a very uh, kind of a quick review of some very important general chemistry topics that must be known and mastered before you begin with organic chemistry. A lot of these topics are talked about again on the first chapter in chapter 11. However, I really want to make sure that you understand these. These are kind of fresh in your mind. Most of these topics should have been taught in your Chem 101 class. I'm hoping they were taught in your Chem 101 class. If they were not, please feel free to um, read more about these online. You can do a Google search on the topics you don't understand. You can do a search in YouTube on other videos. Hopefully the videos I'm going to give you is good enough, but like I said, I'm going to kind of go a little quicker than usual because these are things that you should have already have received. But I do understand some people haven't taken this class in a while. They might have forgotten the information. They might have not learned the information. So I want to make sure that I at least expose you to it um, and that we get you caught up. Please come to office hours. Make an appointment with me to meet with me the first week. Do not feel like the first week is busy for me. Okay, I want to make sure you are starting at that you are starting that you are successful throughout the semester by making sure you understand the information that's important that you need to know for the class. So like I said, this needs to be stuff you need to know from day one. Okay, like I said, this is a review, not a a lecture per se of this class. This is information that you should already know. Okay, just to kind of go over the periodic table, some quick information. Groups and periods. Okay, remember a group is going up and down. So everything in here is group one. This is group one. All right, so groups are the our columns. So here's group one. Here's group two. Okay, here's group three. This is all group three. Group four is where carbon is, and silicon, and um, GE, and SN, which is 10, and PB. All right, group 5, this is all the group 5. Group 6, this is all group 6, group 7, and group 8. So the groups go up and down, okay? The periods go across. So here is period 1. This is period 1. Period 2 goes all the way across. Period 3, all right? So here is our period 4. All right, you got the 4 S's and the 3 D's, if that sounds familiar to you, and then your 4 P's. So this is group 4. I'm sorry, period 4. All right, period 5. Okay, um, and so the groups are the up and down, and we really do this is group 1, group 2. Remember, this is called your transition metals. These are your transition metals. These are your inner transition metals down here, inner transition metals. They fit right in this white space right there. Okay, we are really not going to worry about any of this in this class. In fact, we're not even going to worry about this in this class. You want to know what this class is about? Pretty much this right here. That's organic chemistry plus this. Add that into there. That is it, guys. Okay? People always say organic's so hard, biochem so hard. Well, it's only about, 8 atoms, Ignore the rest of the periodic table. Okay? That's basically organic chemistry. All right? So we're really not going to be worrying about that too much, but I just want to make sure you still remember these terms because I will be using them quite a bit throughout the semester. Okay? Like the transition metals. I don't know why that happened. That's a first. All right, sorry about that. Things like that happen all the time. This group right here, the 7As, especially up to iodine, this group right here, are called the halogens. All right, a few of these groups had names like these were called the alkali metals, alkaline metals. You don't really have to know that, but you do have to know the halogens, okay? Because these are so common and we use them so often. I am just going to call them the halogens: fluorine, chlorine, bromine, iodine. Okay, so the halogens, make sure you know that name. The halogens are the 7A row, fluorine, chlorine, bromine, and iodine or iodine, however you want to pronounce it. Metals and nonmetals. You guys see this step case right here, this black line? That's the staircase. You've learned this in your Gen Chem. Everything to the left of the staircase are metals. Okay, including the things down here, with the exception of hydrogen. That's the only exception. Everything to the right of the staircase are your nonmetals. Carbon, nitrogen, oxygen, sulfur, phosphorus, selenium, halogens, noble gases. Okay, the things on the line in this gray are called the metalloids. Okay, they kind of have both metal and non-metal properties. We really are not going to be talking too much about them. Maybe boron, but if we do, very, very small amount. Other than that, we're really not going to talk about anything else. Like I said, it's this area right in here, which is what we'll be talking about, plus hydrogen. Okay, so I just want to kind of review kind of the metals, the nonmetals, the halogens. Also, let's talk a little bit about bonding. There are two types of bonding. There is ionic bonding, which you learn a lot in 101, and covalent bonding, which we will talk a lot about in this class. Ionic bonding is between a metal and a non-metal. Okay, so something from this side attached to something into here. Okay, so like sodium chloride is an example. Sodium is from here, it's in a 1A, therefore it has a +1 charge. Chlorine is right here, it's in a 7A, it has a -1 charge because of the Octet Rule. Remember, everything wants to have 8 electrons, so chlorine wants to be like its closest noble gas, which is argon. So it has 7 electrons, so it needs 1 more to be octet. Sodium, all right, is right here. Its closest noble gas is 1 up, is neon. That's the closest noble gas. So it needs to lose an electron to become a +1. Remember, everything in the 1As are +1, everything in the 2As are +2, 3As are +3. We kind of skip the 4s. -3, -2, -1. These are the common charges. Okay. So ionic bonds are metals versus nonmetals. Honestly, guys, this is probably the most we're going to talk about ionic bonding this whole semester. So there you go, just to kind of review what it is. Covalent bonding is sharing of electrons, and this is between two nonmetals, 2 or more nonmetals only. If you have a metal in your formula, it's ionic bonding, period. If you have all nonmetals, you have covalent bonding. So it's like a carbon attached to an oxygen, like CO, carbon monoxide. Those are covalent bonding. There are no charges on them. Okay, everything is an octet, equally shared. All right, the structure looks like this. All right, this carbon has a lone pair plus 3 bonds for a total of 8 electrons. 2 here, 2, 2, and 2. So 2, 4, 6, 8 on the carbon and 2, 4, 6, 8 on the oxygen. Remember, each bond counts as 2 electrons. 1 electron from the carbon, 1 electron from the oxygen. That's 2 electrons. So there's 2 here, 2 here, and 2 here. All right, so that is covalent bonding. Okay, so hopefully this is a complete review. You totally understand this. If not, you'd be like, oh yeah, I remember this now. All right, the next two things I want to talk about is valence electrons and Lewis dot structures. We've kind of already talked about it. The valence electrons are the electrons in the outermost shell. Remember shells and subshells and orbitals? Those are the electron configurations. We're not going to go too much into that. Actually, we're not going to go into it at all. I just want you to know how many valence electrons things have and the octet rule. All right, 8 electrons. All right, so remember, everything in the 1A row, I can't even draw straight here, the 1A row have 1 valence electron. Whatever row you're in, that's how many there are. So magnesium has how many valence electrons? Well, it's in group 2, therefore there are 2 valence electrons. All right, group 3, 3 valence electrons. Group 4, 4 valence electrons. Group 5, 5, 6, 7, 8 valence electrons. 5, 6, 7, 8. Whatever group you're in. Now remember, we're ignoring all of these, and we're ignoring this. Don't even worry about it. So everything in the 5A row. So sulfur has how many valence electrons? 6. Iodine has how many valence electrons? 7. Okay. Phosphorus has how many valence electrons? 5. That's it. That's how you know how many valence electrons there are. Okay. Lewis dot structures, remember, So let's start with lithium, beryllium. This just is kind of a shorthand just to kind of show how many valence electrons everything has and if they are paired or unpaired. So lithium, which is right here, let me erase this so we can see everything. Lithium is in group 1, so it has 1 valence electron, so you show it by doing 1 dot. Beryllium has 2. 1 dot here, 1 dot here. Unpaired first. We're going to do a whole bunch of unpaired, and then we're going to start pairing up. If you don't remember, that was Hund's rule. Hund's rule was first unpaired, then you pair. Boron has 3. 1, 2, 3. And this is what's called a Lewis dot structure. Carbon has 4. This is like a fundamental rule you just have to remember. Carbon has 4 valence electrons. Okay, nitrogen has 5. So what do I do with nitrogen? I go 1, 2, 3, 4, whoop, and then the 5th one I go back to the beginning and I pair it up. That one kind of vanished. Let's do nitrogen over here. So nitrogen has 5 valence electrons. 1, 2, 3, 4. Finally, the 5th one is 5. So this, remember, is called a lone pair. And then it has 3 unpaired electrons. Oxygen is 6. 1, 2, 3, 4, 5, 6. 2 lone pairs and 2 unpaired electrons. It's oxygen. Fluorine has 7. 1, 2, 3, 4, 5, 6, 7. And then neon is a full octet. Okay? Remember, the goal for everything is to be an octet. So we're really going to just care about carbon, nitrogen, oxygen, and the halogens. Carbon, nitrogen, oxygen, halogens. Carbon has 4 valence electrons, so as far as an octet is concerned, how many more electrons does carbon want? Well, it wants 4 more. 1, 2, 3, 4. So carbon is going to make 4 bonds, and it can make it with any other nonmetal: hydrogen, nitrogen, oxygen, fluorine, phosphorus, sulfur, halogens, selenium, whatever it wants to make, but it's going to make 4 bonds because it has 4 empty spots to it. Nitrogen has a lone pair plus 3 unpaired. So how many bonds does nitrogen want to make? Well, so here, this is 4 bonds. The answer for nitrogen is 3 bonds. Because you have 3 unpaired, you need 3 more electrons. Oxygen, you need 2 more. And the halogen needs 1 more bond. So halogens only make 1 bond. And then obviously the noble gases don't have any bonds. Okay, so that's Lewis dot structures. We're going to talk a lot more about this in chapter 11 when we start talking about bonding, but I just kind of want to review this information with you guys. All right. All right, that is it for chapter 1. I'm sorry, for the first part of the review. We'll get into the second part on the next video.